All right, we're down to the last problem we can work in this electrochemistry section. And so what we're looking at is current, right? So current is the amount of charge transferred per second. And the SI unit for current is the ampere, right? So it's defined as coulombs per second. So if you have an amp, it's coulombs per second. And an older way of reporting the charge is at a Faraday. So this is the electric charge of a mole of electrons, right? So if you have 9.6 times 10 to the fourth coulombs, that means you have 1 mole of electrons. Okay, so this is the kind of problem we can solve. A current of 1.26 amps is used to drive the electrolysis of water for 7.44 hours. Remember, amperes is charge per time. So if I multiply by time, right, I get coulombs. Go from there. All right, calculate the mass of O2 generated. Okay, the first thing we have to do is just recall how many electrons are transferred each time. So in order to make some oxygen, remember it was 2H2O goes to O2 plus 4 electrons, right? That's from up here. Okay, so each O2 molecule requires or releases 4 electrons, right? And that's going to be important. So then let's see, current, all right, so I'm going to start with the time. So we have 7.44 hours. All right, I know I need to get to seconds because amperes are coulombs per second. So let's see, 1 hour is, we'll do it the long way, is 60 minutes. 1 minute is 60 seconds. Now we're in seconds. So now I can multiply by 1.26 coulombs per second, right? As soon as I see big A, I know it means coulombs per second. So now seconds are going to cancel, and I'm in coulombs. All right, I need to relate this charge then to the number of electrons. And we have Faraday's constant, so let's use that. We know that if you have 9.6485 times 10 to the fourth coulombs, that is 1 mole of electrons. And it takes me 4 moles of electrons to make 1 mole of O2, this relationship. And then finally, 1 mole of O2 weighs what? Periodic table, 32.00 grams of O2. Phew. All right, let's check this and then we'll mash it in. So hours is going to cancel hours, minutes will cancel minutes, seconds will cancel seconds, coulombs will cancel coulombs, moles of electrons will cancel moles of electrons, moles of O2 will cancel moles of O2, we'll be left with grams of O2. Should be good. If everything is true, this should work out. So let's mash that in. And I'm mashing it. You should mash too. Oh no, 7 times 60 times 60. Times 1.26 divided by, in parentheses, because it's scientific notation of 6485 10 to the fourth. Is that right? 6485, yep. Divided by 4 times 32. And Bob is your uncle, just like that. 2.80 grams of O2 will be produced. So it's just a big dimensional analysis problem, right? The only trick, air quotes, is that you have to know that amperes means coulombs per second. So we can turn time, right, into charge and relate that. We're going to do this in lab. We're going to look at the electrolysis of a copper system. So one copper, we're going to build a system with copper 2 ions in solution. We're going to put in 2 copper electrodes. One will act as the anode and the other will act as the cathode. So the anode will be oxidized. It'll disappear, right, as copper solid becomes copper ion. The cathode will get bigger because copper ion is going to be reduced to give me copper solid. Okay, we plug this in. We'll count the time, how many seconds we put the current on there. We'll use our constant current system. So we'll know basically the same thing. We'll have a time, we'll know the current. From that, we'll be able to count the electrons. And we know that copper 2 takes 2 electrons to be reduced. So if I know the number of electrons, now I know the number of copper atoms I reduced. That's here. And if I measure the change in mass, of the anode or the cathode, I can turn that into moles of copper. And so that gives me Avogadro's number. And it'll be super fun.